Okay, this is the Math 3 Unit 4 practice test. Starting with number 1, given the rational function f of x equals -5 over x plus 7 minus 2, state any vertical and horizontal asymptotes. So our asymptotes are found based off of our translations. So I want to look at my horizontal and my vertical translations. I don't need to worry about my reflection at all. So if I have x plus 7, that means I go which direction by 7? Left 7. And if I take my function and subtract 2 from the end, that means I go which direction by 2? Down 2. Okay, this should give me my horizontal and vertical asymptotes. So if I'm going to the left by 7, am I going to hit an x value or a y value on my coordinate plane if I start from 0, 0 and go left by 7? An x value. So that's going to give me my vertical asymptote, which means I write down x is equal to, left 7 is -7. So that's my vertical asymptote. It goes straight up and down. My horizontal asymptote had to go down 2, so that goes through a y value, which means my y is equal to -2. So remember, left and right is your x value because your x-axis goes left and right. Up and down is your y value because your y-axis goes up and down. Does that make sense? All right. Questions about number 1? Okay, number 2. Simplify. Anytime I'm going to simplify, I will factor my numerator and denominator and then reduce my factors. So starting with my numerator, I have a greatest common factor of 7. And that leaves me with 4 minus x. You can write this in standard form first, and it might help you so that when you factor your difference of squares that they match perfectly. But my denominator is a difference of squares. So x times x is x squared. Positive 4 times -4 gives me -16. And then I also know my middle terms are 4x and -4x, which cancel out to 0, which is good because I don't have a middle term on this problem. So let's see what matches. So nothing currently matches, but I do have a 4 minus x and an x minus 4. But I want a positive x and a -4. So if I factor out a -1 from this numerator, what would that make the 7? A -7. And if I factor out a negative, that's going to change every sign that I have. So I have -7. Now I have a positive x and a -4. And then my denominator is x plus 4 and x minus 4. So the x minus 4 over x minus 4 equals 1, which means I'm left with -7 over x plus 4. Taking a look at the numerator one more time, if I would have rewrote that as -7x plus 28, I could have factored out the -7 right away. And then that would have left my binomial as x minus 4. That might have been more simple. All right, so -7 over x plus 4 is that solution, or that simplified expression, not solution. All right, number 3. in order to simplify, I need to factor. So we're going to factor the numerator. We're going to do the short method. So we're going to guess and check this one. X times x is x squared. I need two numbers that multiply to 40 and add to 13. 8 and 5. Very good. Positive 8 times positive 5 is positive 40. 8x plus 5x is 13x. My denominator, we're going to do the same thing, guess and check. X times x is x squared. I need two numbers that multiply to negative 35 and add to negative 2x. Negative 7, positive 5. We can check that by doing negative 7x plus 5x is negative 2x. So we want to check that middle term. We can also check that negative 7 times positive 5 is negative 35. Good. So those are both right. So now we can start to reduce. So any factor over itself equals 1. So x plus 5 over x plus 5 equals 1. And that just leaves me with x plus 8 over x minus 7. But this problem asks for your excluded values. So if at any point you're asked for your excluded values, you want to list what they are. And those are the x values that would make your denominator equal to 0. So what number would I plug in for x in my final solution that would make it equal to 0? 7. Is that the only excluded value? No, because I put a comma, right? We want to check our factored form. So what other number can I plug in for x that would make my denominator equal 0? Negative 5. So positive 7 minus 7 is 0, and negative 5 plus 5 is 0. Questions? All right, now we are getting into multiplying and dividing. So with multiplying fractions, you just multiply straight across. I'm going to put any of my polynomials in parentheses. And once I multiply, you're going to notice I put all of my monomials out front, which doesn't look different for my numerator. But for my denominator, I'm going to put the x squared out in front because it's a monomial. And you're just used to seeing them written that way, so that's why we write it that way. You can put it at the end, and it doesn't change the value, but this helps you know what to reduce. Okay, when you're simplifying, you're going to do your operation first, and then simplify. And the only way to simplify is to factor everything and see what factors reduce. So let's factor this trinomial in my numerator. Most of your trinomials on your test will have an a value of 1, but there is one problem that doesn't have an a value of 1. How do you need to factor if you don't have an a value of 1? Good. Factor by grouping. But this one does have an a value of 1, meaning in front of the x squared, that's a 1. So we don't need to factor by grouping, we can just factor by guess and check. So x times x is x squared. What multiplies to 5 and adds to 6? 5 and 1. 5 times 1 is 5. 5 plus 1 is 6. Okay, this binomial is a difference of squares. What does it factor to?
X times 5 plus 2.
Very good. Oh, I wrote plus twice. Please do not write down that x squared minus 25 factors to x plus 25 times x minus 25. That is not how we do difference of squares. Our last two numbers have to multiply to the negative 25. Some of you are just copying the 25 to each one. All right, so x plus 5 over x plus 5 equals 1. So those reduce. Does anything else reduce? The x's. So x cubed over x squared equals 3x. 3x cubed. I'm going to take these two x's that are in the denominator and subtract them from the 3 in the numerator. So that leaves 1 left over. So 3x. I still have an x plus 1 in my numerator. So the x squared reduced, the x plus 5 reduced, so I'm just left with x minus 5 in my denominator. My excluded values, how many do I have on this problem? 3. 1, 2, 3. So in my factored form, if I set each of these equal to 0, I could solve. On the first one, I take the square root. Square root of 0 is just 0. On the second one, I'm going to subtract 5. And I get x equals negative 5. And on the third one, I'm going to add. So I get x equals positive 5. So 0, negative 5, and positive 5 cannot be your x values. Otherwise, it would make your denominator equal to 0. And if your denominator is 0, then your expression is undefined. All right. Number 5. Division. What should I do? Good. Keep the first fraction and then multiply by the reciprocal of your second fraction. Okay, multiplying straight across gives us 84x to the 4th, y to the 4th, over 504 x, y to the 5th. Now, do you have a calculator on your test? No. So if you don't know that 504 is divisible by 84, then it would take you a while to simplify that. So what you could do instead of multiplying the 7 times the 12 together is show that those are going to be multiplied together, but we're just going to keep them separated, but still show the multiplication operation. Same with the 24 and the 21. So if I decided, let's not multiply those together, let's just multiply them and set them next to each other, I still have factors. Factors are things that you can divide out. What is this numerator divisible by? Give me at least one number this numerator is divisible by. If I do 7 times 12, that means 84 is divisible by 7 and 12, right? So if I reduce by 7, I'm going to divide by 7 out of my numerator. Divide by 7, I get 1, which means I need to divide my denominator by 7. Which number are you going to divide by 7? 21. All right. Over here, if I divide by 12, are these numbers both divisible by 12? Yes, 12 divided by 12 is 1. 24 divided by 12 is 2. Okay, so for my coefficients, 1 times 1 is? Not a trick question. 1. 2 times 3 is? 6. So 1 over 6. Let me check that. 84 times 6. That gives me 24. 48 plus 2 is 50. 504. So 84 times 6 gives me 504. Which means if I divide both of these by 84, I'll get 1 over 6, just like I got here. So you can always check it if you're not sure. Or you can just divide 84 and 504 by the same numbers until you get as small as you can. What about my x's? Where do I have more x's at? On top, so the numerator. How many more in the numerator than in the denominator? 3 more. What about my y's? 1 more y in the denominator than I have in the numerator. So that would just mean I'm subtracting these 4 there. And this one, I'm subtracting from here. So my final answer is x cubed over 6y. Questions? All right, go ahead and flip to the other side. Number 6, another division problem. So we're going to multiply by the reciprocal. And then we can multiply straight across. All of my polynomials I'm going to put inside parentheses. All 4 of these are polynomials. So I'm going to show that these are being multiplied together. How many factors should I end up with in my numerator? 4. How many factors should I end up with in my denominator? 4. So a difference of squares factors to 2 binomials, x plus 2 and x minus 2, for x squared minus 4. For x squared minus 9, that's x plus 3 times x minus 3. But trinomials factor to 2 binomials as well. So let's guess and check for my first set. X times x gives me x squared. What multiplies to 9 and adds to 6? 3 and 3. Positive 3 and positive 3. Okay, for my second one, what multiplies to 4 and adds to 4? 2 and 2. So I get x plus 2 times x plus 2. Let's check those. 3x plus 3x is 6x. That's good. 2x plus 2x is 4x. All right. X plus 3 over x plus 3 reduces. X plus 2 over x plus 2 reduces. Can I factor out negatives from my numerator? No. So I saw some shaking of the head. But if I factored, some people try to do that because they see that these kind of match, but they're opposite numbers. If I try to factor out a negative from x minus 2, what does x minus 2 factor to? Negative x plus 2. So that would still not match positive x plus 2. So I wouldn't want to do that. Which means this can't be simplified anymore, so we need to write our simplified form of all of my factors that are left, which is x minus 2 times x minus 3 over x plus 3 times x plus 2. And you can write those, multiplication is commutative, so you can write those in the opposite order, and that's fine too. Number 7. Adding and subtracting. So the rest of this page is adding and subtracting. How do you add and subtract fractions? Common denominator. Are these denominators the same? No. What can I multiply this fraction by so that my denominator would match the other one? Negative 1. So let's distribute a negative 1 to each of these values. We haven't changed our first fraction yet, but if I distribute that negative 1 to my denominator, I get negative 7 plus x. and then multiplying my numerator by -1, I would get -2. Are my denominators the same now? Yes. Even though they're not written in the same order, this would be the same as rewriting x minus 7, and then I have a positive x and a -7, so that's x minus 7 as well. Which means you can combine your numerators to 3x, what? Minus 2 over x minus 7. Whenever you get common denominators, you want to keep that common denominator in your answer. Don't try to subtract or add the x's together and add the 7's together. All right. If you need to stop me at any moment, just let me know what questions that you have. Number 8. What will my common denominator be?
20y cubed.
Good, 20y cubed. So I look for the biggest number and I look for the biggest variable. I'm going to multiply the first fraction to get to 20y cubed. Or even just say I need to multiply the first fraction by something to get to 20 because we need to make it bigger. So what am I multiplying by? 4. Let's check that. 4 times 4 is 16. 4 times 5y cubed is 20y cubed. I am going to also multiply the second fraction, but don't forget on a subtraction problem, what do we need to do? Change the sign and add the opposite. So instead of subtracting a positive 2, I'm going to add a -2. That'll help me when I'm multiplying my numerator and denominator. So what am I multiplying the numerator and denominator by? Y squared. So I changed it to an addition problem, so I'm going to show that. 20y times y squared is 20y to the third. Now they match, which is good. -2 times y squared is -2y squared. And then we're going to combine these together. Let's go ahead and put it into standard form. I have a -2y squared and a positive 16. My denominator stays the same. What's my greatest common factor of my numerator? -2. You can pull out a -2 or a positive 2 depending on what will help you more. And then I'm left with y squared minus 8. And then my denominator is 20y cubed. If you would like to break up the denominator to show the two different factors it breaks up to, that's fine. Otherwise, you can just tell me if I divide the numerator and denominator by the same number, what am I going to divide by? -2 or positive 2, either way. So if I divide by -2, I get 1. And what would my denominator be? -10. If I divide my numerator by positive 2, it would be -1 over 10. No matter what, if you have a negative in your numerator and not one in your denominator, your solution should be negative. So I'm going to go ahead and represent this negative out in front. Then I still have 1 over 10. Does y squared minus 8 factor more? No, because it's not a perfect, 8 is not a perfect square, otherwise it would. So I'm going to show a few different ways that you could write this one. You can have the -1 up in front of your numerator. You can have the negative in front of your entire fraction. You could have, we talked about this at first, this be a positive 1 and a -10 in your denominator. So that would be y squared minus 8 over -10y cubed. These are all equivalent expressions. Most of the time, if your solution is going to be negative in your numerator or denominator, you'll see it written out in front of your entire fraction instead of just in the numerator or just in the denominator. You can put your numerator in parentheses to remember that this would be multiplied by a negative all the way through. Questions on either of the three forms that I wrote down there? As long as your equivalence holds, you can have any of these three type of answers. All right. Number 9. Subtract. I have to have common denominators again. How do I make these denominators the same? Multiply them by each other. I can't add to get an equivalent fraction. I can only multiply to get equivalent fractions. So if I multiply my first fraction by the other denominator, then I don't have a common denominator yet until I multiply the second fraction by the first denominator. Then my denominators are the same. X plus 3 times x plus 4 is the same as x plus 3 times x plus 4. Don't forget to, with subtraction, we're going to add the opposite. Okay, so I have 6 times x plus 3 over x plus 3 times x plus 4 plus negative 2 times x plus 4 over x plus 3 times x plus 4. Are your denominators the same? Yes. So you can now add your numerators. But you can only combine like terms. Right now, 6 times x plus 3 is not a like term with negative 2 times x plus 4. So instead of adding them right away, let's go ahead and distribute these so then I do have some like terms. What is 6 times x plus 3?
6x plus 18.
Good. What's negative 2 times x plus 4?
Negative 2x minus 8.
Good. Now my denominators are still the same, but now I have like terms in my numerators. These are not like terms because the term they're being multiplied by doesn't match. 6x and negative 2x are both being multiplied by an x, so those are like terms. What is 6x plus negative 2x?
4x.
And what is 18 plus negative 8? In other words, what's 18 minus 8? 10. Okay, at this point, you need to check to see if we can simplify more. How do we simplify? Greatest common factor, which is 2, and I'm left with 2x plus 5, because if I were to distribute, I get to 4x plus 10. Do any factors match in my numerator and denominator? No. So you actually cannot simplify this one more, but you wouldn't be able to tell that unless you factored it. Because if by some chance this factored to 2 times x plus 3 or 2 times x plus 4, then I would be able to simplify. So my final answer can be either of these two. Normally we leave it as the first one that we had, but you can write either of them down. So this is also a correct solution. All right, number 10. What is my common denominator, least common denominator? 15x cubed, which means this one can stay exactly the same. We're only multiplying the second fraction to get there. So what do I need to multiply 5 by to get to 15? 3, and then x squared, because x times x squared is x cubed. What do I do now? Good. Multiply the numerator as well. So this is equal to 2 over 15x cubed plus, good, 9x squared over 15x cubed. Once my denominators are the same, I add my numerators. Let's go ahead and put it in standard form. Which of these terms is going to go first? 9x squared plus 2 over 15x cubed. Can I combine the 9 and the 2? Nope, they're not like terms. Can I factor the numerator? Nope, not a difference of squares. I can't reduce any x values because I don't have one in every single term. I can't reduce by 3 because I don't have one in every single term. So that is actually my most simplified version of this expression. Let's talk about excluded values. At any point throughout your solving process, if your denominator equals 0 for that x value, then that x value cannot be used. So, starting with our very beginning, what number would I plug in to make 5x equal to 0? 0. I could show that by dividing the 5 to the other side and I get x equals 0. What about 15x cubed? 0. 0 cubed is 0. 0 times 15 is 0. So, at any point throughout this, I either have 5x or 15x cubed, so I only have one excluded value. X cannot be equal to 0. Can x be equal to 5? Yeah. 5 cubed is going to give you 125 times 15 is a big number. 5 times 5 is 25. Can x be equal to negative 5? Yes. 5 times negative 5 is negative 25, not 0. Correct? All right, go ahead. Okay, number 11. Given the function f of x equals 1 over x minus 4 plus 2, A, sketch the graph of the function on the xy plane below and label the intercepts, which means both x and y intercepts. Okay, so starting with my asymptotes is where I always start for graphing rational functions. So in order to graph my asymptotes, I need to know what direction we translated based off of this equation. So x minus 4 means what direction do you go from the parent function? To the right 4. And then plus 2 means up 2 from the parent function. So the parent function has an asymptote at x equals 0. If I move that to the right 4, it's now at x equals 4. Let's go ahead and count by 2 so that we can see both sides of our function. So whenever you count by 2s, you have to label your x and y axis. So 2, 4, 6, 8, negative 2, negative 4, negative 6, negative 8. All right, so right 4 would now be right here. That's my vertical asymptote. Let's go ahead and write the equation since we drew in the asymptote. Vertical is up and down. What value do I go through? First of all, it's on the x-axis, right? So I want to write x equals, what number do I go through? 4. So x equals 4 is my vertical asymptote. Then we're going to go to our horizontal asymptote. Paying attention. Let's see. Down 2, we're going to keep our y-axis the same. So I'm going to do -1, -2, -3, -4. So my horizontal asymptote at -2. Oh, thank you. Good catch. Sorry, we went up 2, not down 2. Up 2. All right, so the horizontal asymptote is what? 2, and what axis are we going through? Y. So our equation has to be y equals 2. If you just put 2, you won't get full credit. You have to put y equals 2 because I need to know which direction it's going. Are you paying attention?
Yes.
Write this on your paper. Okay. So now I need a point on either side in order to graph my function, and I also need to graph the x and y intercepts. Which one do you want to start with? Do you want to start with a point on either side, or do you want to start with the x and y intercepts? X and y intercepts. So if I want to find my y-intercept, what do I plug in? 0 for the x value. Good. So f of 0 equals 1 over 0 minus 4, which remember, if it's all in the denominator, means we're going to do that all before we actually divide, and then plus 2 at the end. What is 0 minus 4? -4. 1 over -4 plus 2. That is the same as -1/4 plus 2. So some of you know how to add those in your head because of quarters. Like if I said you owed me 1/4 and then you paid me $2, well, you would have paid me how much extra? Or you can change it to decimals, or this is the same as 2 minus 1/4, right? So what do we have left? 1 3/4. Because if I take a quarter away from 2, I'm left with 1 3/4. You can also write it as a decimal, and that's fine. So let's write out this point that I'm going to graph the point at. What is my x value?
Oh, sorry, 0.
0. X equals 0. And f of 0 equals 1 3/4. So that's my y value. And you can also put 1.75. So we're going to graph that point over 0 up 1.75, which is right here. It says label the intercepts, so we have to label that point. All right, find the x-intercept. That means your y value is equal to 0. So plug in 0 for f of x. X stays the same. How do I solve? We could clear the fraction. How would I clear the fraction? X minus 4 to how many of these? The 1, the 2, and the 0. Okay, 0 times anything is 0. In this first fraction, x minus 4 over x minus 4 is 1. So 1 times 1 is just 1. And then following that, I have a 2 times x minus 4. What am I going to do with 2 times x minus 4? Distribute. So I get 0 equals 1 plus 2x minus 8. 1 minus 8 is? Negative 7. What am I going to do with that negative 7? Okay, when we add 7 to each side, I get 7 equals 2x. What do I do now? Divide by 2. That reduces on the right-hand side, so I get x equals 7 over 2. So what point do I write that as? 7 over 2, comma 0. All right, 7 over 2. More than what? Less than what? More than 3, less than 4. This is 3.5. Okay, 6 over 2 is 3, 8 over 2 is 4. So this is 3.5, which is about right there. Exactly in the middle would be 3. 3.5 is closer to the 4 value. All right, so now I can draw in the function on the left side here, but I'm still missing a lattice point. So I'm actually not going to draw the function in yet. I'm going to wait until I have a lattice point. So let's see. We want to plug in a number to the left and to the right of my vertical asymptote. Bless you. All right. My asymptote's at x equals 4. What number should I plug in? 5. 5 minus 4 plus 2. Okay. What is 5 minus 4? 1. What is 1 over 1? And what's 1 plus 2? 3. So this point is 5, 3. Over 5, up 1, 2, 3. It doesn't look like a lattice point, so we're going to make sure we label it. That's 5, 3. All right, and then we need one on the left-hand side as well. So what number am I going to plug into the left? 3. What is 3 minus 4? Negative 1. What's 1 divided by negative 1? And what's negative 1 plus 2? 1. So over 3, up 1. All right, so I'm going to zoom in on that so that you can see the graph. So these 2 points here were my x-intercepts. This one is 7 over 2, 0, or 3.50, you can write. And then you also need to graph the second half of your function, which is on the other side of your vertical asymptote. also on the other side of your horizontal asymptote. So this part right here is not part of my function. I'm just pointing out what point that is there. I didn't have room to write it. All right, the domain of this function. All of my x values, I'm going to put D below so that I have room to write it. All of my x values from the left to the right. Starting from the left, this goes to the left forever, so I start from negative infinity. Where's your paper? Then get a piece of paper out or ask me for another one. Negative infinity. What is the first x value that is not used? 4. So I'm going to use a parenthesis because I'll never hit that value of 4. And then I'm going to pick back up at 4 because immediately after I have more x values being used. So 5 is being used right here, 6 is being used, all of these numbers are being used from 4 to positive infinity because this side goes to the right forever. So that's my domain. My range is very similar. We're going to go from bottom to top. So do I go to negative infinity on my range? Yes, because this goes down forever. What's the first y value I skip? Go positive 2. And then I'm going to skip over that 2 and keep going to positive infinity because this side over here goes to positive infinity. All right, we already did f and g. So f is x equals 4. G is y equals 2 for my horizontal and vertical asymptotes. State the open intervals on which the graph of f is increasing. So what does open interval mean? Parentheses only, so you don't have to worry about brackets. State the open interval on which f is increasing. Increasing means going what direction? Up. So as we go from left to right, we want to know, is this piece of my function going up or down? Down. Let's look at this part. Is this piece going up or down? Down. Everything's going down. Where are we increasing? Nowhere. So there's no interval for h. Where is my function decreasing? Everywhere where the function exists. So everywhere except for my asymptote. And are we writing down x values or are we writing down y values when we write down our intervals? X values. So the x values of this function match what value that we did up here? Domain. So my domain should be my solution for my decreasing intervals because all of my x values until 4 and then all of my x values till infinity. So we just want to skip over the value of 4. We're not decreasing if I don't have any points there. Open intervals on which the graph of f is greater than 0. And then k is open intervals on which the graph is less than 0. So what does greater than 0 mean? Positive, but which values are positive? Y values. So I want to know if my y values are greater than 0, we're going to be above the x-axis. And if we're less than 0, we're going to be below the x-axis. All right, let's start with Which one are you going to start with, above or below? Above? Okay, so if I start with above, everything above the x-axis should be part of my solution, and I want to write down all of the x values that are above the x-axis. So, that are being used to plot points. So, this is being used to plot a point, -10, -8, all of these points are being used, and to negative infinity. So, we write from negative infinity, and what is the first number where we're no longer above the x-axis? 3.5. At 3.5, we are no longer above the x-axis because we're on the x-axis. And then from 3.5 to 4, where are we at? Below. So we can't use those. Where do we start being above again? 4. After 4, right? So after 4 to positive infinity. And then the only values that were below were a very, very short amount of time of x values. What are the x values for this part that's below the x-axis? Have to be between these two numbers here, right?
Yeah.
What are those numbers? From 3.5 to 4. So if I plugged in 3.6, it would give me a negative solution. If I plugged in 3.7, it would give me a point to plot down here, somewhere negative on our graph. These two, J and K, you'll notice that if you combined them together, you would get your domain. So from negative infinity to 3.5, from 3.5 to 4, that's all this first part of my domain. And then the second part of my domain matches. Questions about number 11? None at all? We all understand number 11?
That's it, 20 minutes.
Okay, do you have a question?
No, I was wondering if it took 20 minutes.
Okay. All right, number 12. What do I do on number 12? Good, so the numerator is being divided by the denominator, so I'm going to keep the numerator together. I have two fractions in my numerator. And then that's being divided by all of my denominator, so I want to keep that part together as well. I have two fractions in my denominator. All right. Order of operations, what do you do first? Parentheses. So I want to add two fractions together that don't have common denominator. So what am I going to do with my first two fractions? Well, let's start with the first one. What do I multiply the first fraction by to get a common denominator? X. What about the second fraction? 2. That better? Okay, so I get 3x over 2x plus what? 2 over 2x. We're going to do the same to the other side. What am I going to multiply this first fraction by? And what am I going to multiply the second one? 5. So I get 4x over 5x plus 10 over 5x. What goes in between these? A division sign. Still need to do parentheses, right? So I'm going to add those together. 3x plus 2 over 2x. When you have a common denominator, you want to keep the denominator the same. Divided by 4x plus 10 over what? 5x. So I should be writing an equal sign as I go here because all of these rows are equivalent to each other. How do we divide fractions? Very good. Multiply by the reciprocal. I'm going to multiply these straight across. So I'm going to put each of my polynomials inside parentheses. Because when you multiply a polynomial times a monomial, where does the monomial usually go? In front. So I have 5x times 3x plus 2 over 2x times 4x plus 10. Can either of those be factored more?
Yeah.
4x plus 10. What are you going to factor out of 4x plus 10? A 2. When you factor out the 2, what do I do with it? Very good. Multiply it to the other 2. So when I divide each of these by 2, I'm left with 2x plus 5. You'll notice that if you were to distribute both of those denominators together, you should get the same answer. So like here, 2x times 4x is 8x squared. 4x times 2x is 8x squared. Then you check the second term. 2x times 10 is 20x. 4x times 5 is also 20x. So I simplified correctly if they're both equivalent to each other. All right, what can be factored out of my numerator and denominator? Or what can reduce? X. X over x equals 1. So they reduce. What about 5 over 4? Does that reduce? No. 5 over 4, 5 is prime, not divisible by 2 or 4. 3x plus 2 and 2x plus 5, do those reduce? Nope, they're not the same factor. They don't match. So my final answer is 5 times 3x plus 2 over 4 times 2x plus 5. Questions on that one? All right, go ahead and flip to the next page. You can, for your final answer, if it was 15x plus 10 over 8x plus 20. Yes, you can write your answer like this. The reason I always factor everything out is to check to see if more things reduce. And I'm okay if you leave it in factored form or if you distribute it back together. This is a more proper answer, but if you write this, they're both equivalent.
I got 15x over ax plus 2.
So
I'm trying to see where I went wrong with that. At first I had something like that.
you would want to check as you go whether you have right here 3x plus 2. Did you add 3x plus 2 together? Yeah, you have a 3x plus 2 right here. And do you have a 3x plus 2 right here? Okay, so when you multiply 5x times 3x plus 2, I'm writing my monomial out in front and the 3x plus 2 afterward. So I don't know if you just forgot to transfer it over or if you tried to distribute it. If you multiplied 5x times 3 and didn't multiply it by the 2, then that would become an issue because you would have to distribute it if you're going to multiply it through. Otherwise, we just leave it outside. That answer your question? All right, number 13, solve. When we solve, we can do what? If you're solving, yes. Solving means you have an equal sign. You can only solve if you have an equal sign, and if you have an equal sign, you can clear the fraction. You can only clear fractions if you have an equal sign. So on any of the other problems we've done so far, we couldn't do that. But now we can because we have an equal sign. So what are we going to multiply both sides by? 2x. So So multiply by 2x to move it to the other side, and multiply by 2x over here. That means on the right side, 2x over 2x reduces. What is 2x times 5? 10x. And then on the right side, the 2x is reduced, so all I have is a 3. What am I going to multiply by now? The x plus 2. So multiplying x plus 2 to both sides, the x plus 2 over x plus 2 reduces, which means 10x is equal to 3x plus 6. Good. What did you just do right there when you went from 3 times x plus 2 to 3x plus 6? Distributed. Now how do I solve? Good. Subtract the 3x. We're going to continue on the right. 10x minus 3x is 7x. So 7x equals 6. What do I do now? There we go. We are awake. X equals 6 over 7. I would just leave it as a fraction because you won't have a calculator. The excluded values are the values that make the denominator equal to 0 at any point. So we don't want x to equal these numbers because they would make our denominator equal to 0. Let's start here. What number would make my denominator 0 here? Negative 2, because negative 2 plus 2 is 0. What about on the right-hand side? 0. So then you look throughout your solving process. Only the next line had a fraction in it, and it was the same as the one that I started with. So I don't have any more to check, any more denominators to check. Checking your most factored denominator would help you the most on that. Any questions about the exclusions? All right. Number 14. Can I clear the fraction? Yes, because it says solve and we have an equation. So I'm going to multiply every single term by x minus 1. Ooh. I almost don't have room to do that. Okay, in the first fraction, my x minus 1 reduces. In the second term, I didn't have a fraction, so I won't get a fraction by clearing fractions. And in the third, on the other side of the equal sign, my x minus 1's also reduced. So now I already don't have any fractions left. What should I do? Distribute. So we want to work with this most simplified version possible. So we distribute and combine like terms. Combining like terms on the left-hand side, what do we get? X minus x is 0, so yes, we're just left with x squared. Now, yeah. Now, am I going to have a trinomial or not? Yes, because I have an x squared term, I have an x term, and I have a constant. Whenever you have an x squared term and an x term and a constant, you can make a trinomial. How am I going to make this into a trinomial? Subtract. So I heard subtract x squared. We can do that. I also heard subtract the right side to the left. Now, why would I want to subtract the right side to the left and move 2 terms instead of just moving 1 term? Your x squared term would stay positive, which tends to be an easier path to take. But if you like the challenge, then go the other way. So x squared minus 4x minus 5. I moved both of these terms to the left, so 4x minus 4x is 0. and 5 minus 5 is 0. So I have 0 on the right-hand side. When you have a trinomial equal to 0, how do you figure out what x is? Starts with an F. Factor. We're going to factor this trinomial. And we're going to use the short method because my a value is equal to 1. So x times x gives me 1x squared. What numbers multiply to negative 5 and add to negative 4? Positive 1 and negative 5. That's correct. 1 times negative 5 is negative 5. 1x plus negative 5x would be negative 4x. How do I solve for x? Equal each of your factors to 0, then subtract 1 to the other side, add 5 to the other side. I get x equals negative 1 and positive 5. So let's write down our exclusions before we write down our solutions, because it's possible that one of those may not be a solution. So what value can I not have for x that would make my denominator equal to 0? 1. X cannot be equal to 1. Are either of these solutions 1? No, negative 1 is not the same as 1. So I do have two solutions for x. It's negative 1 and positive 5. Questions? Okay, number 15. When I have an equation, can I clear the fractions? Yes, only when you have an equation. Okay? The only way I can clear fractions is to know what factors are in my denominator. So I have one factor of x minus 5. How do I determine what two binomials multiply to x squared minus 3x minus 10? What do I have to do with this? Factor it. So we're going to keep the first fraction the same and factor the denominator of my second fraction. So let's use the short method because my a value is 1. So I know that x times x is x squared. What numbers multiply to give you negative 10 and add to give you negative 3? Negative 5 and positive 2. Negative 5 times positive 2 is negative 10. And negative 5 plus 2 is negative 3. Did you get it? Okay. Now, how do I start clearing the fractions? Multiply every single term by the factors in my denominator, starting with x minus 5. It doesn't matter which one you start with. We're just starting with the one that I saw first, which was on the left. All right, so x minus 5 over x minus 5 reduces to 1. So I'm left with 1 times 2 is 2. Or I'm just left with a 2. X minus 5 over x minus 5 reduces as well. And I'm left with 10 over x plus 2. What is 1 times x minus 5? X minus 5. You could distribute the 1, but you know 1 that times anything is just whatever you multiplied by. Now what am I going to multiply everything by? X plus 2, my second denominator factor. Now, because I'm multiplying by x plus 2, I am multiplying that entire right side by x plus 2. So make sure you can leave x minus 5 in parentheses from the beginning, or you need to put it in. If you're doing a binomial times a binomial, each of them have to be in parentheses. So now my x plus 2's reduce, and that leaves me with 2 times x plus 2. What's 2 times x plus 2? 2x plus 4. After that, I'm going to add 10 because everything else reduced. And on the right side, I have x minus 5 times x plus 2. How do you multiply x minus 5 times x plus 2? You can distribute each term in the first binomial to each term in the second, or you can use the area model. Either way, if you're distributing, you're doing x times x. Same thing here, x squared. Then you're doing x times 2, which is 2x. Then you're doing negative 5 times x, which is negative 5x. And then you're doing negative 5 times 2, which is negative 10. So either way, you should come up with these 4 terms. What does that give me? Okay, where else do we see x squared minus 3x minus 10? Yeah, because when we factored that denominator, I was left with x minus 5 times x plus 2, which is what we're now multiplying together. So you could have just went back to the denominator because you already know x minus 5 times x plus 2 is x squared minus 3x minus 10. All right, now I have terms on both sides. I have x squared terms, I have x terms, I have constants. What do I need to do? Add 4 and 10, like terms. I still have x squared, x, and a constant, so I can get a trinomial. What should I do? Yeah, because if I have a trinomial, I want it equal to 0, so we're going to move the 2x and the 14 by subtracting both of them to the other side. Why do I want my trinomial equal to 0? If you have a trinomial equal to 0, then you can factor it and set each of the factors equal to 0 to solve. But you can only do that if your trinomial is equal to 0. Otherwise, you don't know what to set it equal to. So when I factor this, what does it factor to? Good. So x times x is x squared. And then we want to multiply to negative 24 and add to negative 5. So I heard that negative 8 and positive 3 would multiply to negative 24 and add to negative 5. Is that correct? Yep. What are these two terms multiplied together equal to? Good, x squared minus 5x minus 24. And that is also equal to 0, right? So if I have two factors that are equal to 0 when they're multiplied together, then I can set each of them equal to 0 to solve for x. X equals 8 and negative 3. Now, before I write those down as my two solutions, I need to check my extraneous solutions. So my excluded values are the values of x that would make my denominator equal to 0. So let's start right here. What would make my denominator equal to 0 in my first fraction? 5. So that means x cannot be equal to 5. Then in my second fraction, it's easiest to see the denominator in the factored form. So what would I plug in for x for these two values? 5 and -2. We already have the 5, so then we just need the -2. Are there any other denominators other than x minus 5 and x plus 2? No. So those are my only two excluded values. Does that mean I have to cross off one of these two? No, neither of them are 5 or -2, so I have two solutions here, 8 and -3. Okay, going down to 16. We're just simplifying on 16. How can we tell if we can simplify a rational expression? Or how do we simplify rational expressions? What do we have to do to them first? Factor them. Factor completely. That's the first thing to do. So we're going to start with the numerator. What factors out of my numerator? 5, and I'm left with x squared minus 4. So that's a greatest common factor. That's one way to factor. We're going to do greatest common factor in the denominator as well. What's my greatest common factor there? X. So I'm left with x squared plus 5x plus 6. But I can still factor each of these more. How do you factor? What method do you use to factor x squared minus 4? Difference of perfect squares. So that factors to what? Good. X plus 2, x minus 2, or x minus 2, x plus 2. Doesn't matter. Either way. Please make sure you're not putting x minus 4 and x plus 4. That's a big mistake, or a common mistake, because we're just like factoring, I don't know, too quickly. You want to make sure -2 times +2 equals -4. All right, we're also going to factor this trinomial right here. And because the a value is 1, we're going to use guess and check. So x times x. What multiplies to 6 and adds to 5? +2 and +3. So we'll check that. 3 times 2 is 6. And then 3x plus 2x is 5x. So that works. What simplifies? The x plus 2. Anything else? Nope. Now, you can multiply these back together, or you can leave it in factored form. I'm okay if you leave it in factored form. But we also need to find our exclusions. Now, why is my final answer not x equals a number? Good. There's no equal sign when I start. It's an expression that I'm simplifying. Simplifying is different than solving. Solving would be find what x equals. And you have to have an equation in order to solve. Simplifying is just making it as simple as possible. What x values can I not have for my denominator? -3. -2. Make sure that's x plus 2, so you would plug in a -2. Anything else? 0. So if I plug in 0 here, I get 0 times 3 times 2, which would be 0, right? So, +2. Can I have an x value of +2? Yes. If I plug in 2, that'd be 2 times 5 times 4. 2 times 5 times 4 does not make my denominator equal to 0. In the numerator, do I care if my numerator is equal to 0? No. 0 out of a number, as long as it's not 0, 0 out of 7 is 0. 0 out of 100 is 0. 0 is okay to have in your numerator, just not in your denominator. So then, for this part of 16, I'm just going to draw an arrow because I don't have room to write it up there. But you get 5 times x minus 2 times x plus 3. Please do your best to write all your answers on the line if you have room to do so. Okay. 17 and 18 are two of the word problems like that will be on the test. There are a couple word problems, like 2 or 3 on the test. So we need to talk about rational expressions. Usually when you have a rational expression equation, we're talking about a rate, meaning rate per person, meaning average cost per person, or a rate meaning time, like speed is a rate. You know, you have like how many, let's see, how long does it take the fountain to drain? You're talking about how many, I don't know, an entire fountain per hour, how much of the fountain per hour can drain. So we're talking about rates the entire time. So let's start with our first rate. So in the middle of an outdoor shopping center sits a large fountain. With only valve number 1 open, the fountain will take 5.5 hours to drain. So the rate for that is 1 over 5.5 or 5.5 times the amount of time. Because if you multiplied by the entire amount of time, you would get a 1. And what does the 1 represent? 1 whole fountain drained. So 1 whole. It's easier to see with the 4. So if it says it takes, for valve 2, it takes 4 hours to drain the entire fountain, how much of the fountain is drained per hour? For each hour, a quarter of it is drained. Because it takes 4 total hours. So that's 1/4 per hour. And then if you were to multiply it by 4, it'd be 1 full fountain. Okay, and then why are we adding these together? Yeah, question says both valves are open now. So you have a rate of 1 times the rate of another, or added to a rate of another, but the time remains the same. So as 1 hour passes, then we'd have how much of the fountain drained? Well, it would be, let's see, 1 over 5.5 plus 1 over 4, and we would solve from that. But we don't want to know as 1 hour passes. We want to solve for the entire fountain draining. So you add these together and set it equal to an empty fountain, which would be 1 full fountain is drained. So again, these are rates. You're doing how much per hour. And this is 1 over 5.5 per hour. 1/4 per hour equals 1 whole fountain. Now we can start to rewrite this and multiply by t, our time divided by 4. And how do I get rid of the denominators? It's an equation, so can I clear the fractions? Yeah, what do I multiply by? How do you clear fractions? You multiply by the denominator. So you can start with 4 if you would like. And that gives you 4t over 5.5 plus 4 over 4 reduces to t. And 1 times 4 is 4. Now what do I multiply by to clear the other fraction? 5.5.
For the beginning part, why would you multiply by t?
Right here?
Yeah.
because it's a rate times the amount of time. So like this 1/4 T, if 1 hour passes, 1/4 of the fountain is drained if this is all on its own. If 2 hours pass, 2/4, which is 1/2 of the fountain is drained. If 4 hours pass, the whole fountain is drained based off of this one rate. So you have to multiply by the time in order to determine how much of the fountain is drained. And then from here to here, you're just multiplying 1/4 times T. So 1/4 times T over 1 is T over 4. All right. 5.5 and 5.5 reduce because anything over itself equals 1. So I get 4T plus 5.5T equals what? 22. Very good. What's 4T plus 5.5T? 9.5T. What do I do now? Divide by 9.5. See. If you want to, because you won't have a calculator on your test. If you want to multiply both of these to get a fraction, what would I multiply my denominator by so I don't have a decimal anymore? 10. So I multiply each of these by 10. I get 220 over 95. You could also multiply both of them by 2, right? Yes. So if I multiply by 2 instead, what is 19.5 times 2? 9.5 plus 9.5, or 9.5 times 2 would be 19. What's 22 times 2? So this is 44 over 19 hours. Yeah, if you multiply this by 2, it's the same as adding it to itself. Right?
Oh, yeah, I know that.
3 times 2 is 6. 3 plus 3 is 6.
Why'd you put 220 over?
So I asked what I would multiply by to not get a decimal anymore. And you can multiply by 10, but this would have to be reduced. So if you could want to multiply by 10 and then divide each of them by 5, it'd be the same as multiplying by 2.
So just
Yeah. Yeah, if you wanna do long division on your paper and leave it as a decimal, but you just won't have a calculator on your test. So you need to remember that yes, you may leave it as a decimal, but you have to show your long division on your test. All right. Questions? You guys have a question?
we can use non-scientific, right, on the test.
Mm-hmm. Yeah, non-scientific is fine. If you have your own. All right. Actually, maybe not. I'm fine if you use. You can use a non-scientific calculator. What? We'll talk about that at the end, after the video. Okay. All right. Number 18. An initial group of players, X, decided to buy their coach a $180 gift. So I have $180 being split between X amount of people initially. So if you talk about a cost per person, what's that called? Average cost. Okay, so if we split the entire amount by X amount of people, the average cost is initially 180 divided by the number of people. But then 4 more players decide to join the group, and what happens to the average cost? Decreases by 12. So you're going to take the average cost and decrease it by 12. This is a cost. This is a cost. And then your new cost is going to be the same total divided by how many people?
4.
So we had initial group of X, and now we have 4 people?
So X plus 4.
4 more people, so X plus 4. That means 4 more people than what we originally had. So, average cost per person decreases by 12, and you have a new average cost for a new amount of people. That's what this means. Questions about setting this up? Well, now we're going to solve it. So, in order to solve this, I want to clear the fractions. What am I multiplying everything by? X. We'll do X plus 4 next. Either way, you can start with either one, but I heard X first. So then that gives me 180 minus 12X equals 180X over X plus 4. Now what do I multiply everything by? X plus 4. Okay, what is 180 times X plus 4? 720. And negative 12X times X plus 4? Good. Make sure you know that this is a negative 12, so we're going to distribute and get negative 12x and negative 48x. Sorry, negative 12x squared and negative 48x. And on the right we have 180x. What do you notice is on each side? So we can subtract that from each side. And write this in standard form. Now here's a hint. Those numbers are really large and you don't have a calculator on your test. So you're probably not going to use the quadratic formula or something like that or factor with these large of numbers. So what do? Greatest common factor. What numbers are all these divisible by? 12. So I'm going to factor out a negative 12. What does that do to every one of my signs? Changes them to the opposite, and I still divide by 12. Thank you. All right, what do I do with the negative 12? Good, right now it's 12 times something equals 0. So I'm going to divide by negative 12 on each side. Does that change anything on the right hand side? Nope. X squared plus 4x minus 60 equals 0. It's a trinomial equal to 0. What are you going to do? Factor it. What multiplies to negative 60 and adds to 4? Yep. X times x is x squared. 6 times 10 is 60. Which one needs to be negative so that my 4 is positive?
Wait.
Negative 6, positive 10. 10 minus 6 is 4. Do we get that? Okay, I have two solutions for x right here. 6 and negative 10. Which one is the correct answer? 6. Because I can't have negative 10 people. You can have negative numbers and answers in some places, but in this case, you can't have negative 10 people. Okay, go ahead and flip to the other side. All right. On problems like number 19, it is a procedure problem, meaning do you know what steps to follow in order to find common denominators of rational expressions? And the first step to follow is to factor all of the what? Denominators. So my first denominator factors to x plus 2 times x minus 2 because it is a difference of squares. Okay, you'll notice that I'm writing out each of my fractions in order to show my work, and I want to get to a common denominator. So the x plus 2 matches in 2 of these. Which one's missing in x plus 2?
The x.
Good. The x. So I need, and whatever I multiply to the denominator, I have to multiply to the. Good. Now, we're still missing some factors.
X minus 2.
X minus 2 is missing from both of the last two terms. And now what am I missing? X. So this one has everything now, right? This one's missing
An x.
X. And this one's missing
An x.
X. So now I'm going to put the X times X minus 2 and X plus 2 times X minus 2. And what is my denominator? Good. Normally our monomial goes out in front, so I'm going to go ahead and put the X out in front. X times X plus 2 times X minus 2. Or X times X minus 2 times X plus 2. Either way is fine. Yeah. How'd I get what? So this first fraction was missing an x in the denominator because this one on the very right had one, right? So if I have to multiply it to make these denominators the same, then you also have to multiply it to the numerator. So do you see how we multiplied this last one by x plus 2 and x minus 2? This first fraction already had those, but it didn't have this x. So I need to multiply it to the denominator. And these are equivalent fractions, so in order to make an equivalent fraction, you also have to multiply it to the numerator. It would be like saying if you had 1/6 and 2/3, you're multiplying this fraction by whatever factors are missing, which is 2. I have to multiply this by 2, which means I also have to multiply the numerator by 2 in order to do 1/6 plus 4/6 and then add straight across. That's what we're doing here, but with polynomials. Yeah. All right, number 20. Solve each equation algebraically. And then at the bottom of the page, mark with an X or a check mark whether each equation has no real solution, one real solution, two real solutions, or infinitely many real solutions. So starting with the first fraction, what are we going to multiply everything by? Or first equation, sorry. First equation, what do I multiply everything by? 2. The 2's reduce, and I'm left with x equals negative 8 over x plus 6. What do I multiply everything by now?
X plus 6.
X plus 6. What is x times x plus 6?
Shouldn't the x plus 6 be multiplied by 2?
What x plus 6? I multiplied this fraction by 2, and I did negative 4 times 2 is 8.
Oh, so you don't have to multiply the x plus 6 by 2?
No, because we're clearing fractions. We're not making, so up here we were making equivalent fractions because I didn't have an equation. It's an expression. This one, we're clearing fractions. So when you clear fractions, you're multiplying the number to the other side, which means you only multiply it in your numerator. It's like multiplying by 2 over 1. Okay, what's x times x plus 6? X squared plus 6x. X plus 6 over x plus 6 reduces. What should I do with that 8? Add it to the other side so that I have a trinomial. And then you factor it. X times x is x squared. What multiplies to 8 and adds to 6? 4 and 2. Good. X equals
Negative 4.
and negative 2. Let's talk about our extraneous solutions. What can x not be equal to?
Negative 6.
Negative 6. Is that one of my solutions that I got?
No.
No. So this problem, will I cross anything off?
Nope.
No. So 20A has
2 solutions.
2 real solutions. 20B. What am I going to multiply each side by?
Negative 3. Like x minus 3.
X minus 3. That reduces in my first fraction. Oh, so I shouldn't have a fraction anymore. X minus 3 over x minus 3 is 1. So x equals 5 times x minus 3 over x plus 5. What do I multiply everything by now?
X plus 5.
X plus 5. All right, x plus 5 over x plus 5 reduces. What should I do now?
Distribute.
Distribute. And I get x squared plus 5x. 5x minus 15. What now? Good. Subtract 5x. Add 15. 5x minus 5x is 0. Negative 15 plus 15 is 0. X squared, oops. Negative 5x minus 5x is also 0. So I get x squared plus 15 equals 0. How do I solve this? How do I solve for x? Subtract 15. I get x squared equals negative 15. What do I do now? Square root, so plus or minus the square root. X is equal to plus or minus I root 15. How many real solutions do you have? None. Those are imaginary solutions, so you have no real solutions for 20B. Okay, 20c. To clear a fraction, we're going to multiply by our first denominator of x minus 5. That gives me x over minus 5 over x minus 5 is 1. And 8 times x minus 5 over x. Then I'm going to multiply each fraction by x to clear my second denominator. So I get x equals, well, 8 times x minus 5 because these x's reduce. X over x equals 1. Then I'm going to distribute 8x minus 40. Then I'm going to get all of my x's to one side. So I'm going to subtract 8x to the other side. So I get negative 7x equals negative 40. Then I'm going to divide by negative 7. So x equals 40 over 7. My extraneous solutions are x cannot be equal to 5 or to 0. Because if I plug in a 5, 5 minus 5 is 0. If I plug in a 0 for the second fraction, then that would make my denominator 0. But 40 over 7 is not equal to 5 or 0, so I have one real solution. Then for the last one, I'm going to go ahead and factor my denominators before trying to clear my fractions. That's going to help me see some factors that match. If I have factors that match. So I factored this wrong. Let me try that again. I need to take out a 2, and I'm left with 3x plus 1, because both of these are divisible by 2. There we go. 2 times 3x is 6x, and 2 times 1 is 2. That helps because then I have two of my factors that are the same in the denominator. So these factors of 3x plus 1 match, which means if I multiply the 3x 1 times each side, they reduce on both sides, and I get 4 over 2 is equal to 2. Now I could multiply by my denominator again, or I could just reduce this fraction now. 4 divided by 2 is 2, so I get 2 equals 2, which is always true. There should be infinitely many solutions, but you have to list your exclusions. So x cannot be equal to whatever makes my denominator equal to 0. So in this case, if I set 3x plus 1 equal to 0, I subtract the 1 to the other side, and then I divide by 3, I get negative 1/3. If I set 6x plus 2 equal to 0, I would also get negative 1/3. So x cannot be equal to negative 1/3, but any other solution it can. So this is infinitely many real solutions. And then 21 is our last problem for the practice test, and it says solve the following equation for g. So I'm going to start by multiplying by my denominators. My least common denominator is gxy. I'm going to go ahead and multiply by all 3 of those denominators at one time. You can do them separately. When you do them all at the same time, you need to be careful about what reduces. So only if you have the factor in the numerator and the denominator at the same time does it reduce. So g over g is 1. That leaves me on the left of my equal sign with x times y times 1, which is just xy. In my second fraction, the x is reduced, so g times y times 1 is gy. And then I'm adding my next fraction where my y is reduced, so 2 times g times x is 2gx. Now, remembering what I'm solving for g, so I want to get g isolated, which means if I want to get it out of everything on the right-hand side, let's take it out as a greatest common factor. So the left-hand side is not going to change, but if I take that out as a greatest common factor, it's the opposite of distributing. So g times y would give me gy, and g times 2x would give me 2gx. And then to get g by itself, right now it's g times this set of parentheses. So we're going to divide the set of parentheses to the other side in order to get rid of it. Uh-oh. It's y plus 2x. So the y plus 2x reduces, and the g is all alone. So g is equal to xy over y plus 2x. That's xy over y plus 2x. Please make sure you write it as equation because you are solving for g.